So first is the hormone secreted. Our group decided to present about the hormone melatonin. It is a hormone that can be metabolized from the amino acid tryptophan (TRP) via the serotonin pathway, making it a type of amino acid-derived hormone. Second is the location of the secreted hormone and mechanism of action. The hormone is produced by the pineal gland in the brain and synthesized highest at night, stimulated by neural input from a structure called suprachiasmatic nucleus in the hypothalamus. Melatonin binds to melatonin receptor type 1A, which are G protein coupled receptors, and there are two subtypes in human, one melatonin receptor MT1 and two melatonin receptor MT2. The melatonin receptors are expressed in various tissues and parts of the body. MT1 receptors are expressed in many regions of the central nervous system (CNS), in the retina, ovary, testes, mammary gland, coronary circulation and aorta, gallbladder, liver, kidney, skin, and the immune system. Meanwhile, MT2 receptors are expressed mainly in the central nervous system (CNS) and also in the lung, cardiac, coronary and aortic tissue, myometrium and granulosa cells, immune cells, duodenum, and adipocytes. By binding to melatonin receptors 1 and 2, the downstream signaling cascades have various effects in the body. MT1 receptor activation inhibits the adenylyl cyclase, and its inhibition causes a rippling effect of non-activation, starting with decreasing formation of cyclic adenosine monophosphate (CAMP) and then progressing to less protein kinase A (PKA) activity, which in turn hinders the phosphorylation of CAMP, responsive element binding protein (CREB) binding protein into pCREB. MT1 receptors also activate phospholipase C (PLC), which affect ion channels and regulate ion flux inside the cell. Meanwhile, the activation of ML2 receptors, currently called MT3, leads to phosphoinositide hydrolysis. Hence, when melatonin binds to MT1 and MT2, it sends signals to other receptors that start a cascade of actions which ultimately resulted in effects of melatonin physiologically on our body.
Three functions of hormone. First, managing your sleep-wake cycle. Next, convey information concerning the daily cycle of light and darkness to body structure. And third, short-term treatment of trouble sleeping due to jet lag.
The effects of the deficiency of the melatonin hormone. A deficient production of melatonin can result in anxiety and mood disorders, lower basal body temperature, insomnia, elevated estrogen or progesterone ratio, and immune suppression associated with cancer. Excess melatonin is associated with seasonal affective disorders, SAD, lowered estrogen or progesterone ratio, low thyroid and adrenal function, and hypotension. Melatonin deficiency. The body is expected to produce sufficient amounts of melatonin for sleep. Unfortunately, modern lifestyle factors can contribute to insufficient melatonin production. This can lead to problems falling asleep at night and waking up in the morning, as well as a feeling of tiredness throughout the day. Causes of melatonin deficiency. Age and disease. As stated above, melatonin levels decrease as we age. After age 90, melatonin levels are 20% of what they are in younger adults. Studies also suggest that neurobiological diseases such as Alzheimer's, schizophrenia, and dementia can contribute to decreased melatonin levels. Second, light exposure. Responding to darkness, our pineal glands release more melatonin at night. As a result, increased light exposure, especially at night, can suppress melatonin secretion. Melatonin signal disruption. Like all hormones, melatonin signals to the body that it's time to do something, in this case sleep. However, if your melatonin receptor is malfunctioning, melatonin signals can't perform their roles.